anything. Did y'all see the solutions I posted too? Did I post them from the old book? Okay, I posted the wrong solutions. I'll get them. I'll get the right ones posted. I'm sorry. They'll remind me at the end of class, and I'll do that. I'm sorry. Okay, Avery, which one did you say you felt like just wasn't right? 20. It probably approached different limits from different sides. You said you did have problems putting it in your calculator? And you will, that's setting us up for what we're doing today. It's one thing if you get the same number as something else if you don't, but most of the time you want them to be the same number. That's just approaching from the left and approaching from the right. Okay, let's see. Putting them in can be a struggle a lot of times. Y'all see that? X sign, make sure you're in radians, remember. The natural log of the absolute value of X. So I'm going to close my absolute value, I'm going to close my natural log, and I'm going to close my sign. Right? 1, 2, 3, 1, 2, 3. X times the sine of log of the absolute value of X. I think I'm going to try a zoom trig on this and see. What? 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 I don't think you have a Spanish option.
I promise you. Because look, I was wondering, you see how I did like 16 times 16? I was wondering why it said that. I was like, wait, was there an update or something? Yes, it's in Spanish.
Your whole thing is in Spanish. Oh, look, idioma español.
Oh my gosh. I was so confused last night when it said that. Wait. Okay, great. But look. Oh, yeah.
There your y equals? I bet you left off a parenthesis. Oh, you don't need 3 because your absolute value is different than mine. Okay. So I told you to graph it, but really you don't even need to graph this one because this is the one where we fill out the table, right? Funky. It's kind of a cool little second graph for your table. It looks like it's approaching 0. Is that right? Is that what y'all got? Approaching 0 on the positive side. What about the negative side? It looks like it's approaching 0 from both sides. Does that make sense? Y'all remember what that E means, right? Just scientific notation. 0.1. It's just approaching from that side. I bet negative 0.1 is positive, yeah. So, and if you look at the graph as it approaches, as we're getting closer and closer to 0, it looks like the point on the graph is 0, 0, but there's probably a hole there or something. But still, from either way you come closer and closer to zero, the y value is getting closer to zero. Does that make sense? All right, so look at the graph. When I put in a negative x value, right, I'm getting closer and closer and closer to zero. But until it gets there, it's positive, right? So if I do negative 0.1, I should get a positive number. But if I do 0.1, it's going to be negative. But they're still coming in, approaching in closer and closer to the same value. Does that make sense? Like if I come from the left side and I get closer and closer to zero, y is getting closer and closer to zero. So this y might be like 0.2, 0.1, 0.01, 0.001. And over here, this might be negative 0.2, negative 0.1, negative 0.01, negative 0.001. Both of them are coming closer. They're just coming from different directions. And well, this one. You will. If it's coming from the positive side, it should have been negative. It should have been positive. Oh. Does it jump down some? Let's see. Negative 0.01. Oh, I guess it does kind of go down a little bit. It goes down past, because at negative 0.04, it is a negative. That's okay. That's interesting. Interesting. But zero is still undefined. What else? 19? 10. Oh, that's the fraction. 10 to the x minus 1 divided by x. Should have a vertical asymptote at 0, right? So the question is, what am I approaching from either side of that, which is what I'm looking at in the table. So let's see, we'll graph it first. Let's see. 0.1, 0.01, 0.001, it looks like it's approaching 2.3. Is that what you put? From both sides. You plugged in what? Yes, and so your calculator will start kind of, if you do too many, kind of glitching out almost on those. Yeah. Say that again. We could even do this. I don't know that it's going to make sure it looks the same. the extra parentheses there around the 10 is not necessary. And yours looks like that. Your equation. It looks like that, but your graph doesn't. Your graph does a better job showing it. That's all it is. Mine, you're not seeing mine. Remember, we know it's undefined there at 0, right? Because your table doesn't look like mine. If you put 0.1 in your table, what do you get? 1.25? Oh. Good now? Okay. What else on your homework? Y'all ready to talk about limits? Y'all need a break in between? No. All righty. Let's do it then. Y'all make sure you eat breakfast before Coach Beck comes in and takes it. I set some aside for second block so they'd have some, but I left y'all plenty. So. All right, ready, Freddy? Everybody's favorite. Y'all are really so quiet, it makes me anxious. I feel like, I don't know. It makes me nervous. It's been good. I know, thank you. It's been good. All right, do y'all remember limits from pre-cal? Do you know what a limit is? Limits. Say it again. So it's right. It's what you get close to as you get close to a certain value. So let's say I have the limit as x approaches. We'll just do something easy to start with. As x approaches 2 of, and we'll give us a function. Let's just say x plus 3 is my function. That says, what is the what value does the equation get close to? What y value does it get close to as x gets closer and closer to 2? Right? Do y'all remember that? So in the case of this, I could just plug it in, right? Because this is defined at 2. If it's defined at 2, well, that's pretty easy. So this would just be 5. This is just a straight line, right? And it's got the point 2, 5. So that's not a problem. But then we also talked about, did we talk about one-sided limits in pre-cal? I can't remember what we got to and what we did. I feel like we did. Where we'd say, okay, the limit as x approaches 2 from the left. Did we do it like that? Okay, okay. So this is a left-hand limit as opposed to a right hand, which would be the limit as x approaches 2 from the right. Let's see. Let me give you an example. Let me give you a graph and let's talk about it. Let's say f of x. Yep. And left hand just means start from the left and come up towards 2 from the left side. And right hand means come towards 2 from the right side. Remember that? Okay. Tell me when you're good. Okay. let's call this g of x. What is the limit, like that point? The limit as x approaches -4 from the left of g of x. It's just 6. I'm coming in from the left-hand side, getting closer and closer to -4, so I take the y value there. Even though the point's not defined there, the limit is defined. You don't have to, your point doesn't have to be defined for your limit to be defined. Just coming back to you a little bit. So as I come in and I'm tracking it from the left, I'm getting closer and closer to this 6 value here. How about the limit as x approaches -4 from the right? 2. No? Okay, so if I'm approaching -4, first on the left-hand side, right? If I come in from the left and I come closer and closer to 4, as I come closer and closer to 4, I'm getting closer and closer to the value of 6, right? But if I come in from the right, I'm getting closer and closer to 2. There's no part of the graph on the right side of this, so I can't come in from here, so I come in. It just means that it's defined there. It could be defined or undefined. That doesn't impact it having a limit there. The limit is just it's getting closer and closer to that point, but it doesn't necessarily mean, and we'll get into all that when we talk about continuity too, but in the case of this, g of -4 is not the same thing as the limit as x approaches -4 from the left. In other words, the function defined at that point, -4, is not the same as both points side and line. They can be different, and that's okay. Other questions about that? How about, I think I just jumped through that way too soon. How about the limit as x approaches -4? What if you just had, what's the limit as x approaches -4? Does not exist. You're exactly right. Why does it not exist? It's coming into 2 different y values there, so it doesn't exist. I can do the one-sided limits there, but I can't say that the limit itself overall exists here. So everybody remembers does not exist, D and E, does not exist. So in order for the limit to be defined, so if the limit from the left equals the limit from the right, then it all, I should put that, then it also equals the limit as x approaches a of x. Okay? But in order for this to be defined like this, it's got to be coming in, they've got to be equal here. If the left-hand limit and the right-hand limit exist and are the same, then the limit at that specific point is the same. So for instance, if I were looking at same graph, what is the limit as x approaches 0 from the left? 2. Look at your y value there, right? And I'm approaching 0 this time. It's 2, right? As I come in this way. How about the limit as x approaches 0 from the right? 2. Therefore, the limit as x approaches 0 of f of x is also 2. I ran out of room, I'm sorry. So if the left-hand limit is the same as the right-hand limit, then that's also the limit at that particular value. Yep. The limit is the value that it approaches. So as you approach, or as you get closer and closer to whatever this number is, what is your y value doing? The closer you get to the, so over here, the closer I get to, and let's look at the general limit, the closer I get to 0, what's the graph doing? What y value is it getting closer to? 2. It's right. It doesn't always stop, no. It could be if, let's call this, what did I call the other one? G, let's call this h of x. We'll call this 5. What is the limit? And I'm only going to come in from the left side because my function is only defined on the left side of this value. What's the limit as x approaches 5 from the left of h of x here? Negative infinity. The closer I get to 5, the further down it goes. Does that make sense? Let's look at this one. Yep. This is typical calculus plugging the hole. That's supposed to go through -1. Sorry. This function is defined as g of x, and it is x squared minus 1 over x minus 1 anytime x is not 1, but it's 1 when x is 1. Does that make sense to you? This function, it can't be 1, right, because there's a hole there. If I factored the top, the factors would cancel. It cause a hole, not a vertical asymptote. Y'all remember that? If I'm starting to talk Greek, tell me, because I don't know what y'all remember and what you don't. So if you don't remember, tell me and I'll go back and refresh you. But so this is a hole because the factors, the x minus 1 and the x minus 1 will cancel because this is really x minus 1, x plus 1 cancels, which creates that hole. That's why my hole is there. But we plugged the hole. So it's a removable discontinuity. We plugged the hole, gave it a value at 1. Okay. So now let me ask you some questions about it. Tell me, looking at this graph and the equation here, what is the limit as x approaches 1 from the left? Two. Are we all in agreement? As I come in from the left and I get closer and closer to 1, my y value gets closer and closer to 2. You okay there? What is my limit as x approaches 1 from the right? It's still 2, right? If I come in from the right, I'm still getting closer and closer to the same y value, right? What's the limit as x approaches 1? It's still 2. And so the whole is literally 1 point, but it gets really, really. I mean, I'm talking like 0.9999999, and then the y value is 1.9999999. You see what I'm saying? I mean, like it just leaves out just that specific value. So yes, it stops there, but at that particular value, the point is 1, 1. But notice the limit. The limit as you come in from the left and the right is 2, which means that the whole limit at that number is 2. What is g of 1? Now they're different. Just because you're defined at a specific value doesn't mean that that's the value of your limit. Does that make sense? Yes, no, maybe. Let's do another one. I'm going to pull this one from your homework. This is number 50 on your homework. You don't even have to have the equation on these. Okay, this is 2 and this is a whole. 1, 2, 1, 2, 3. All right. What is the limit as x approaches 2 from the left? Oh, sorry, I should have put, this should be actually at 1. This should be the 0.21. Sorry, it doesn't look like it, but it is. That's the 0.21 and this is the 0.23. Not to scale. So now what's the limit as x approaches 2 from the left? 1. Do we all agree? You see why? As I come in from the left side, I'm coming down this piece and I'm coming closer and closer to 2 and I'm getting closer and closer to the y value of 1. Does that make sense? What if I come in from the right? It's still 1. It's still right there, right? As I come in from the right, this still equals 1. What does that tell me about the limit at 2? It equals 1 also. Even though there's not a point there, the limit exists because the left-sided limit and the right-hand side limit are the same thing. If these two equal, then this is the same. That the only thing that other point is doing is defining the function at 2 to say that it's 3. Oh, no, not for this particular part, not for there. Now, if I was asking you the limit as x approaches -1, yeah, you'd look at the other part, but no, not for this part. Let me show you a picture and you tell me some things about it. This is for 43, by the way. Skipping all around. I try my best to do problems from your homework so you know what you're looking for. All right, 1 and 2, I know that's not the scale I'm trying to. Let's see, 1 has an open, -1. This is a proper here. This is 1, this is -1. Does the limit, you tell me true or false. The limit as x approaches 1 from the right is 1. the limit as x approaches 1 from the right but not just a closing circle. If you approach 1 from the right, this is the right, right? As I come in this way and I'm getting closer and closer to 1, what is my y value getting closer to? 0. So that's false. That would be 0. How about the limit as x approaches -1 from the right? Is that 1? Yes, yes, yes. Sorry, I'm looking from the left. Yes. So that is true. How about plug it in further? Because by these properties, I could split each one up and then add it together. Let's get to something a little bit harder. What happens what happens if you try to substitute in and you can't? Can you use substitution here? That's the limit, yeah. I know I could, by those limit properties, I could split this up into two separate ones, right? But if I use substitution here, I have an issue. What's my issue? Oh, what? I get a 0 on the bottom. Okay, so maybe, so what happens? What if substitution? Doesn't work. Because if I sub in here, right, I'll get 2 squared minus 3 times 2 plus 2 over 2 squared minus 4, which gives me something over 0, which I can't have. So I got to back up and punt, and I got to say, okay, let's see if we can do some algebraic manipulation. What do I mean by that? Somebody already said what happened there. Might not be an asymptote, there might be a what? If there's a hole, that means it's removable, right? Can I remove it? Can I remove it from the equation? And how? Factor the top. Let's factor the top, right? If I factor the top, what does that look like? What multiplies to 2 but adds to -3? T minus 2. Right? Does that multiply to -2? Add to multiply to +2, add to -3. Are y'all okay? How at the bottom, does it factor? How? Uh-oh, I see a hole. So now if I do that, remember I can't forget it because it's still defined in the function. It's still a hole there, but as far as the limit goes, well, now I can do the limit as x approaches 2 of t minus 1 over t plus 2. Can you do substitution now? Yes. 2 minus 1 over 2 plus 2. We're trying to find, remember, there's a hole there, so it's not defined right there. So what value am I getting closer and closer to? Good morning, Coach Collins. How are you? Welcome. Yeah. Their brains are working overtime right now. Yeah. Mhm. Well, since the leading coefficient was 1, I just did a shortcut. So what multiplies to 2t squared but adds to negative 3t? So I did negative 2t. Sorry, I skipped that step. Yeah, so remember how we looked at those graphs that did this, but then had another point here? So that's what's happening here. The hole is plugged, and the hole is going to be plugged, but this limit here, it's approaching 1/4 from both sides. That's not the plug. That's going to be right. Right. Does that make sense? You don't have to worry about the plug right now. Right now, just worry about finding the limit here. Are y'all okay? Let's graph it and see what it looks like. X squared. Make sure you put that top in parentheses. Minus 3x plus 2 divided by. What were we approaching to? What was x? It was the limit as x approaches what? 2? Let's see. Let's go 1.99. 1.9999. Looks like it's getting closer and closer to 1/4, right? How about if I approach from the other side? What approaches 2 from the other side? Not 1.99, but 2.0001. A little bit bigger. See how it's still getting closer and closer to that 1/4, even though it's not defined on the graph. So algebraic versus graphically. Do you see the difference? And you see how we manipulated it to work there to find out what that limit was as we approach that hole? You okay? All right, try one on your own. Try this one. What is the limit as x approaches 0 of 4 plus x squared minus 16? Will substitution work here, by the way? See that right off, right? Why doesn't it work? That's right. Give me 0 in the bottom. See you later. Y'all have a magnificent, marvelous song. You got it? Okay. Do you know what to do? Yes. Okay. What y'all got? Everybody get 8? I essentially, I took an x out of the top and left me with x plus 8 over x. I took one x away from everybody is what I did. I just skipped the step of GCFing it out. I think I will stop there. Save the trig stuff, like I said, because we'll need some time to work on that. Let's do page 70 to 71. This is going to look like more than it is because a lot of these are look at the graph and examine the limit. Yeah. You're not solving, you're not setting it equal to 0, you're plugging 0 in for x. You're subbing in. You're trying to get to the point where you can sub in because that's the easiest thing to do algebraically. Let's do look at 28. I'm sure we'll have to work that one tomorrow, but I'm trying to save your trig ones for later. 34. We'll talk about step function tomorrow. These look like, this one looks like a lot, but this section is they give you the graph and you just tell the limit of each one, so those aren't bad. Okay, that's it. I know, I'm sorry. Oh, that's it. Huh? It's tough. Try it. You'll probably struggle with it, but try it. It's a complex fraction. Yeah. Don't get bogged down in it. If it takes longer than what I anticipate it taking, just let me know. Huh? Limits. We're still in 1-1. Limits and continuity. This is just limits.